Hi dear students, welcome to the first lecture series video of electrostatics, and this is a 12th year 12th standard first chapter is electrostatics. I will take this chapter into two parts as per the Ncert. First chapter is electric charges and electric field, and the second chapter is electrical potential and capacitance. So we'll start with the first chapter in the Ncert textbook, electric charge and electric field. Please write down the heading on your notebook, electric charge and electric field. I'll write it here, the chapter name, electric charge and electric field. This is the chapter name. Electric charge and electric field is the chapter name. It's the first chapter in the Ncert textbook. Okay, so we'll go one by one topic. The first topic is called charge. So write down the first subheading called charge. Okay, at least you have heard about the term called charge. Where you have heard about the term called charge? Now normally we'll say mobile phones are charging. Correct? Laptops are charging. So all the electronic devices, most of the used electronic devices can able to recharge it. Okay, so we are pushing something into this one. So charging is something called an energy. We are transferring some energy. So what is the exact definition of charge? What is mean by charge? Every matter in the universe. What is mean by matter? Matter means either it is a solid substance or it's a liquid substances or it is a gas substances. Any substances in the universe will possess something called a mass. Okay, mass and weight is different. Weight is called mg, mass is simply called m. Mostly in your first year you have learned about what is the difference between mass and weight. So every matter in the universe possesses something called a mass. Okay, so for example 2 kilogram sugar. So sugar is a substance, sugar is a matter, so which possesses something called mass called 2 kilograms. So 2 is the mass. Similarly, every matter in the universe possesses a property called charge. So charge will have three values. Either charge is positive value, or charge is negative value, or charge is a zero value. So one statement I am framing will be here. So charge is nothing but, you can highlight the first point, every matter, first point, every matter have charge. Every matter have charge. So whatever available in the universe, every matter will have charge. Now I am putting it as a two statements will be here. Every matter will have a charge. I can say every matter will have some mass. So a matter will have mass, massless matters are also will be there. Every matters will have possess charge. Okay, so what is the charge? Charge means charge is a property. So it's a matter property. So I can say it is a matter property. A matter will have a property. Okay, a matter will have a property. Another property other than charge is called mass. So charge is also a matter property. What are all the charges will be there? A matter mass. Mass in terms of gram or kilogram, different unit we will say. Similarly, the charge will have a different values. Okay, what all the values will be? A charge is either positive value, or charge is a negative value, or charge will have something called neutral value. Neutral means what? Means zero charge, there is no charge. Now the question is, when will say a matter? Matter means any substances. A substance will have, a matter will have positive charge, negative charge, neutral charge. Positive charge means if a matter leave the electron, if a matter leave with the electron, a matter is made up of a large number of atoms, right? So an atom is consist of neutrons will be there, protons will be there, electrons will be there. So if that matter is leaving an electron means that matter is giving an electron, leaving an electron. Then this that matter, if it is leaves an electrons, then that leaving of electrons will give rise to a positive charges. And in another way, if that matter is accept the electron, I can say accept electron. If it is accepting the electron, then the matter is going to negative charge. So positive charge understood, negative charge understood, then what is neutral charge? The matter is not accepting or matter is not giving charges at the same time. Here leaving the electron means I am giving an electron to somebody else. So I am just throwing electron out of me. So I am giving something. So I have a deficiency of electron. Correct, I have a deficiency because I am giving something. For example, I have 100 rupees. Now I am giving 20 rupees to somebody. How much will have? I can say I have 80 rupees, but I have a deficiency of 100, which means I don't have 100 but I have 80. So that deficiency is called positive, and if I am getting extra some rupees to me, then I can say I have more than 100 rupees, which means I am gaining something. Then it is negative charges. Now if I am not giving and I am not accepting, the number of electrons and number of electrons and the number of electron means it's a negative charge. Number of proton is opposite electron, which will have positive charge. So if a matter is consist of equal number of electron and equal number of proton, then it is called a neutral property. So neutral property also I am quoting here. A word neutral is called what we can say, same number of, it is called same number of electron plus same number of proton. Then that material is neutral. We know an atom is electrically neutral because atom will be containing same number of electron and same number of proton. So a substance can acquire more electron, then it is negative charge. A substance is giving an electron or donating an electron, then become positive charges. The number of electrons, which means the presence of electron, is something called negative charges. So number of electron and number of protons are same in a substances, then or in a matter, then it is called a neutral charge. So we learned about what is called charge and the different properties of the charge. It's not like property, this is just a definition of charge. What is a charge? We'll summarize in short. Every matter will have a charge, like mass. Okay, if you take any substance, you have mass. Similarly, every matter will have something called a charge. It's a matter property similar to a mass property. Okay, it is a property of a mass, a matter. And this charge will have either positive, negative or neutral. So how we'll say a matter is positive? Because the matter can donate an electron, then we can say that matter is a positive one. If a matter or a substances or an element will accept an electron, then it is negative. If it is not donating, not living, and the number of electron count is equal to number of proton count in a substances, then it is called a neutral. So this is the definition of charge. We're going to see what is a unit of charge. That is the next one. The next point will be is equal to unit of charge. What is actually the unit will be here? What is the unit of charge? Unit of charge is given as called coulomb. C-O-U-L-U-M-P. It's called coulomb. Okay. So coulomb is the unit and whose notation is just a letter called C. So coulomb is a unit of charge. Understood? Okay, just note down this point. Next point is related to the properties of charges. Okay, what are the properties of charge? So the properties of charge, this is a definition of charge. Properties of charge is different from the definition. Properties means what are the peculiarities of that charge. It's a positive charge or a negative charge. What is a speciality? What is a property of that charge? Let's move to that topic. So write down the next heading on your notebook. It is called properties of charge. Write down the next heading on your notebook. Properties of charge. So we'll go and write here properties of charge. What is a property of charge? Okay, what is the first property of charge? Number one, charge is transferable. charge is transferable because, for example, I'll take one example. What is meant by transferable? Which can the charges can flow from one body to another body. For example, if I have a body called A and if I have a body called B, okay, A will have some positive charge 6, I am putting 6 coulomb charge, and B will have no charge, which means 0 coulomb. So I can say 6 coulomb, it's positive charges, so positive means deficiency of electron, and B is a neutral one, that is no charges for B. So when these two bodies are in contact, so A and B are in contact, what will happen when A and B will be in contact? What will happen? A having charge, B having not charge, so A will transfer the charge. A will transfer. So this is a term important. A will transfer the charges. So charges can be transferred from one body to another body. And the next one is charges can be transferred from one body to another body, but at the same time the charge is a scalar quantity. So charge is a scalar quantity. This is the second property. Charge is a scalar quantity. What do you mean by scalar quantity? Scalar quantity, in the sense, in the first year physics you have learned like there are two types of physical quantities are there. Either it is called a scalar quantity or it is called a vector quantity. So scalar quantity means a quantity will have only magnitude and no directions. For example, mass a 2 kilogram of a substances of a matter, if I am saying, so it's a 2 is a magnitude will be there and kilogram will be the unit of this one. So what is the direction of mass? We cannot say direction of mass. So a parameter will have both magnitude and direction, then it is called vector quantity. For example, I'll tell you an example called force. In Newton's laws of motion, first year you have learned about F is equal to ma. Everybody will know who are learning physics, F is equal to ma. What is F is equal to ma? It is the equation of forces. So now I'll say F is equal to 10 Newton. Force will be equal to 10 Newton. What it is indicate to us? 10 Newton is a force in which I am applying. So in what directions I will apply? Then you will ask next question. I am applying a force in what direction? Either from like this or to the bottom or to the bottom or to the bottom or to the top. So you can apply the forces in any direction as you are wishing. So force will have direction. So a quantity which has direction 10 Newton, then along with the 10 Newton will say this is in left, this is towards right, this is towards northeast, for example. So if you say directions along with the magnitude and unit, then it is called a vector quantity. Here charge is not a vector quantity, charge is a scalar quantity. So charge is a transferable one. So two properties we have, and the third property, charge is quantized. Charge is quantized. What is the meaning of called quantized? Charge is quantized in the sense, this is a concept is called quantization. Means Q is equal to Ne. This is called quantization. Means number of electron into charge of electron. If you are multiplying this one, this is called quantization. I'll take an example. Suppose I have a matter, I have a particle, or I have a substance, or I have an element. Suppose I am saying like that, see here 1 electron, 2 electron, 3 electron. Now I am asking what is the quantization of the substances? You will say there are 3 will be there. So I will say is 3 electrons. So 3 electrons are the quantization of the substances. Here what is the value of E? Quantization Q, it's nothing but called a charge. Charge will have a unit also. Now what is the value of E will be there? Electric charge. What is the value? Minus 1.6 into 10 power minus 19 coulomb. This is the charge of an electron. So if you are multiplying 3 into the charge of electron, you will get a Q is equal to Ne format, and this format is called a quantization property of the charge. So 3 properties are there, just note down the 3 properties. And we'll going to see the next property of the charges, and this property is called charge, which is something called conserved. Charges is conserved. What is mean by conserved? Charges is we are learning about something called energy conservation. So same way something called charge conservation. So we'll see what is called the charge conservation. That is the next property. So we have learned 3 properties, and I'm continuing with the property, the 4th properties. Okay, what's the 4th properties means? Charge is conserved. Charge is conserved. Conservation you have learned in biology, conservation you have learned in physics, you have learned in chemistry. All subjects you have learned about conservation. Conservation means always conservation means before happening some incident, there are some value will be there. After happened some incidents, there are some values will be there. So if both values are equal, then it is called conserved. I'll tell you an example. For example, I have one system. Okay, this is I call it as system A, and I have something called system B. So I have 2 systems will be there. This is before happening some incident, this is after happen some incidents. Now here I have a body called A, here I have a body called B, or 2 particles in the system. So these particles will have, as like the previous example, 6 coulomb charge, and this particle will have 2 coulomb charge. Now if this board, now this is the previous condition, this is the initial condition. Now what I am going to do means I am connecting these 2 bodies. Okay, so if I am going from system A to system B, in between what is happening means I am connecting these 2 bodies, then I am separating it. If I am separating it, what will happen? What is the total charge will be here? You will say 6 plus 2, which is equal to 8 coulomb is the total charge. So when it is these 2 bodies are connecting each other, the charges will flow from higher charged body to the lower charged body, and both the charges will made equal. So charges is transferable, right? Here higher charges, less charges. So charges will transfer from this body to this body. At the same time, this charge transfer will happen until both bodies will get the same charges. Now total 8 coulomb. So what will be the charges of one body? 4 coulomb. Now 4 coulomb. This is before an incident is happening. This is an incident, this is a process, and this is after the incident. So before the incident, on incident, after the incident. So now if you say what will be the charge, I will say 4 coulomb plus 4 coulomb is equal to 8 coulomb. Now I can say before an incident is equal to after an incident. So I am putting before an incident, BI. This is just a short form for us to understand it. Before an incident is equal to after an incident. If this process is still holding good, then we will say charges is conserved. Charges can be conserved. And we have the final property, the 5th. The final property is called charge is invariant. So I'll put it like a charge is, I'm writing here, invariant. Invariant. What is meant by charge is invariant? So this is the 5th property. Charge is called invariant. Invariant means wording itself you will understand that charges is not changing. Okay, charges is not changing means suppose you assume you have a disk. Okay, or instead of a disk I'll put it this pen with me itself. So now this will have some charges. Okay, everywhere you assume like charges will be here. Now if it is like this and these charges are not moving on the body, then I will say in the next subsequent chapters you will learn more about it. If a charges is not moving, which will it have electric field and no magnetic field. Magnetic field we will learn more about in magnetism, moving charges and magnetism chapters, but here charges are not moving, charges are constant. If charges are not moving, then there is no magnetism, only electricity, electric field will be there. So charge will be, suppose I am assuming 10 electrons will be there, then according to quantization, what is the total charge? Q is equal to Ne, 10 into E. 10 is a total charge on the body. Now I'm assuming this pen is rotating like this in a very fast way. Is there is any the body is rotating? If body is rotating in the sense, or the body is moving like this one, or the electrons, the 10 electrons which are in the pens are moving to and fro. If these electrons are moving to and fro with the same speed, listen my wording, with the same speed, constant speed, then what will happen? Electric field will be there, magnetic field, when charges are moving means magnetism will produce. So when charges are moving back and forth with the constant speed, no change in speed, constant speed, electric field will be there, magnetic field will be there. Any change in the number of electron? No change in number of electron. Electrons are just moving, so total charges still will be the same, which means Q is equal to Ne. So if an electron is moving, or a substance is moving, or a matter is moving, charge is something called invariant, which means charges are not changing. Now the third example I am taking, the charges are moving but not with the constant speed. If it is not moving with a constant speed, then what will happen? Three things will happen. Electric field will produce, magnetic field will produce, radiations will produce us. But any changes in the number of charges? No change in the number of charges. So whatever happened to the system, whatever happened to the system, in the sense irrespective of the velocity, whether it is a time varying velocity, we call time varying, which means it is not constant, it's keep on changing. If the velocity or the speed is keep on changing, then also charge is invariant. In other case, if the velocity of the charges are constant, then also charges are invariant. If the charges are not moving at all also, then also the charges is invariant. So this is the fifth property. Okay, so we have learned about what is the definition of charges, and we have learned about the few properties of the charges. Okay, method of charging. Method of charging. So what do you mean by method of charging? So what are the possible method of charging? So there are basically three methods of charging will be there. And the first one, the number one, the first method is called friction. First method is called friction. How frictions help to charge? What is friction means? You can consider like an example, you are rubbing two materials each other. If you are rubbing two materials each other, what will happen means the charges are developed on one of the body will get transferred to the next body. That is something called friction. Charges are generated due to the rubbing between the two bodies, and the charges will get transferred from one body into another body, and this is called friction. So in short, I'll just note down rubbing of two bodies. Okay, so rubbing of two bodies will create charges, and which will transfer from one body to another body. It's quite simple. And the second one, charging by induction. Charging by induction. The word is important here. I'm just highlighting with inductions. What do you mean by induction? Induction means charges are transferred, or charges are actually generated in one body. I'll take an example. Suppose I have a rod like this, and the rod is charged with the positive sign. What do you mean by positive? How this rod get a positive sign? Because the rod is leaving some electron, as we have learned in lecture series number 1. So it's leaving some electrons, so it become positive charge. Now I'm assuming I have a metallic sphere will be here. This metallic sphere, if I'm placing very closer to this positive charged rod, then what will happen? The charges are here, it is a positive charges, here this board is neutral charges. When it is placed near to the positive charges body, here the charges, opposite charge will get induced. Opposite charge will get induced. Opposite charge will get induced in the sense, here it is positive, here it is negative. If you are giving here negative, then positive charges will be getting induced. So a negative charge will be induced because of the presence of a nearby positive charge. This is something called induction. If on this periphery, if it is generated with the negative side, then the other side of the sphere, here the opposite side will be induced with the next charge, which means positive charge. Now this is one case. Now the same way, the same steps I am repeating, have a positive one, negative charges are generated here. Now if I connected this side, now what is the charge of this one actually now? So charge of this one I am taking capital Q and charge of this one is taking small q. I know capital Q is positive but small q will be equal to 0. Now the same situations, but only difference in the second diagram is I am giving an earth connection. Okay, so what will happen here? Positive charges will be here, right? All the positive charges will be positive, means it is left to the electron. It has positive nature. Earth will have collection of negative charges, so which will get neutralized, which means there is no positive charges will be on other side, because it is earthed. Earthed means zero potential, 0. So this side will make it to 0. Now what will happen? This is maybe considered the first step, this is considered the second step, and in the third step I am repeating the same experiment, but only difference is that after doing the second step, in the third step I am removing the ground connection. If I am removing the ground connection, what will happen? This negative charges whatever available will be here on this side, all these negative charges will distributed across the body. Now what will be the charges of this body? Now the charges is negative, Q is negative, here also Q is negative, but here Q is positive. So what we understand from this theoretical concept, if you have a positive charged body, a negative charge will be induced on the nearby side, other side will induce positive charge on this spherical body, but still it is a neutral. But if you are giving an earth connections to this one, that area is converted into a zero potential. Earth will also have zero potential, a neutral potential, 0. So 0 voltage will be there. So these charges will have got removed from here, only negative charges will be getting presented. Now the neutral body I converted into a negative type of body. Now if I removing this earth connection, the body whole totally become, these negative charges will distribute throughout the body and the body become in negative charges. So induction in the process where there is no physical connections between the two bodies, but one body is very closer to the next one. That property is called induction. Whatever you are giving one charge, the nearby area, the opposite charges will be getting induced or generated. That is a concept behind this one. Okay. Then, so first property is called frictions. This is the first one, it's called friction, and the second one is charging by induction. Now we have one property is also where there, the third one, it is called charging by conduction. This charging by conductions already we have learned. Conduction already we have learned in the previous lecture series also with an examples. Okay, so I am rubbing this area will be here to make it the first property, remove it from here. So we'll keep with this third property will be here. Third property is I am again writing charging by conduction. So conduction means this is the things which we have already learned in the first lecture series also. For example, if I have a body will have 6 coulomb charge, the body number A, and body number B will have 2 coulomb charge. Hope you have remembered this one. So if these bodies will be connected and after some time the body will get separated. So when it is connected, what will happen? There is a physical connections between these two bodies. Physical connection means charges will transfer from higher body to lower body. Now the body A and B will have the equal charges. What is the equal means? Here it is totally 8 coulomb, so it become 4 coulomb and 4 coulomb. This is another concept also we discussed with the help of this charging by conduction, which means, hope you have remember, this is something called conservation of charge. Hope you have remembering. What is conservation of charge? Before an incident is equal to after an incident. So here in charging by conduction principle, there is a physical connections between the two bodies are happening. Because of that, charges will be getting transferred from one body to another body, and this is a third method of charging method. So induction is a charging method, and an uncharged body we are made it to a negative charged body, so we are charged the body. Here also, here it is a 2 coulomb, or if you take in another example, like if it is a 0 coulomb, then it's an uncharged body. This is a charged body. If this is connected together, instead of 4, what will be the number will come? These two bodies, 6 plus 0. It is easy to find the number. What you have to do means you have to add the charges totally, 6 plus 0, which means 0 coulomb, divided by total number of bodies. How many bodies? 2 bodies will be there. So 6 plus 0 divided by 2, how much you will get? I am writing here 6 plus 0 divided by 2, how much? It's 3. So this body will have 3 coulomb, this body will have 3 coulomb. Now the body B is initially uncharged. By the method of charging, I converted into 3 coulomb of charges. So there are 3 methods we have learned, either by friction, if this body will have no charges, if you are rubbing these 2 bodies, charges are generated maybe in this body, which will be getting transferred to the other body. This is the first point. And second point is induction. Induction means there is no physical connection. One body nearer to the another body will induce the opposite charges, but overall it will have 0 charges, but by doing some earth connection and removing the earth connections, we can make it to be a charged body. And the third one is the method of conduction. An uncharged body or 0 charged body can be converted into a charged body, or in another way, if in the previous example we have taken 2 coulomb. 2 coulomb means less charge. Less charge, then 6 plus 2 totally 8 will be here. As I told, 4 and 4 will come here. In that cases, the 2 coulomb charge we have raised to 4 coulomb cases. But in this example, whatever available in the current board is 6 coulomb and 0 coulomb. 0 is an uncharged one, and which is now converted into 3 coulomb charge. So 3 method of charging. Okay, now hope you understood what is a principle of charging. And next, hope you understood all this formula and concepts are important, will be here. Based upon that, questions may come.